Okay, there are a couple net ionics that are going to be on the test. And the first net ionic that you need to know is that metal oxides in water make bases. So we will do the smooshing method, which is just basically react them and put them all together. You can double replace them, but it's easier to recognize this as a metal oxide and think about what the base would be as a result. So the base here is going to be calcium hydroxide. But this is a strong base, and so we're not done just leaving it like this. We can check it is balanced. There's 2 O's, 2 H's, and 1 Ca. 2 O's, 2 H's, and 1 Ca. But this is strong, so the final answer here will be Ca plus 2 plus 2 OH minus, because it will dissociate in water. That will be the final answer. Okay, lithium oxide is a metal oxide and water, so it's going to make lithium hydroxide plus 1 minus 1. This lithium hydroxide is a strong base as well, so it would be lithium plus OH minus. I'm going to rewrite that because we wouldn't write it with parentheses. Okay, but we need to make sure it's balanced. We have 2 O's on this side and 2 H's and 2 Li's, so 2 and 2 would take care of that, and that's going to be your answer for the lithium hydroxide. Okay, so metal oxides make bases. Non-metal oxides must make acids. So smoosh them all together. You're going to get H2NO3, which is not the correct net ionic. NO3 is minus 1 and H is plus 1. So we're going to have HNO3 here. That's going to be a difficult one to balance. Your book actually says that it will also make this additional product, which would be HNO2. And to balance it, we could have 2 NOs here. That is definitely more difficult than the type that's going to be on the test. The ones on the test are going to be more straightforward, like SO2 plus H2O. Put it all together, H2SO3. This is weak. HNO3 is strong, so that would separate into plus and minus. HNO2 is weak, so that would stay together. The other type of question on the net ionics in the test is going to be something about a titration or reacts with the base. So we might have HOBr is titrated with OH minus, so that must be the reaction. OH minus plus HOBr. This isn't a weak acid, so we're going to get H2O plus OBr minus. Alternatively, I could ask you something like NaF is titrated with H plus, or hydrochloric acid, we'll say HCl. So you might have to start out like this, NaF plus HCl. You would see that it's going to make NaCl plus HF. NaCl is an alkali, so it's soluble, so this is plus and this is minus. NaF is an alkali, so it's soluble, this is plus and this is minus. HCl is soluble as well, plus and minus. So we cancel the things. HF is weak, it's the exception. So chlorine goes away, sodium goes away, sodium goes away, and we're left with our final answer. F minus plus H plus makes HF. Okay, so sometimes students are confused, they're not really sure about the Na, but the Na goes away because it comes from something strong. It's always a spectator, and the Cl also is going to go away, and we'll only be left with those two things reacting. You could call this H3O plus as well. There will also be a solubility one, so don't forget, that would be something like lead nitrate plus maybe sodium sulfate, and you need to recognize that the alkalis are soluble and nitrates are soluble, so the final answer here would be Pb plus 2, SO4 minus 2, PbSO4 is the final answer there.